All right, 5.3, graphing. Graphing. And so we're going to take a look at graphing and really graphing of the kinds of things that we're doing is going to lead us really into higher math. We'll deal a lot with graphing this year, but when you guys get to Algebra 2, we'll deal a ton with graphing. And we'll graph all kinds of things. Now, so far we graphed points. We're going to graph lines, and that's what we'll do mostly. We'll even do some V's. They're absolute values. They're pretty cool. And then later on when you get to Algebra 12, we'll even do some exponentials. An exponential looks like this, if it's an exponential growth, which is pretty cool. If you're investing, you want your portfolio to look like that, because that means it's going up. And if you can get it over here where it starts going up steeply, usually time is the independent variable and amount is the dependent variable, right? The longer you invest it, the more it should be. Unless you make a poor investment, it goes down. All right, stock market could go down. But exponentials and all kinds of things that we will end up graphing. All right, where did I end up there? I have no idea. Come back, wherever you are. All right, let's see. There we are. Okay, so anyhow, graphing. All right, to get there, we've got to set up a couple things first off. And the first thing I want to talk about is what's called the vertical line test. The vertical line test. And we all know what a vertical line is. All right, vertical is this way, right? That's a vertical line. It goes like that. This way is horizontal, that way is vertical. And the vertical line test is a simple test that you can use to determine if a set of points or even a graphed function relation is or is not a function. So we're going to use this vertical line test to determine if something is a function or just a relation. Now, last night you guys did that in a bunch, right? Figuring out whether or not these pairs are functions or relations. Now we want to do it with a graph. Is something graphed a function or a relation? It's pretty simplistic. If no vertical line exists that will intersect, and here's the key, more than one point. If no vertical line exists that will intersect more than one point, then it's a function. And I'll explain a little bit more here in a minute and try to tie into what we were talking about yesterday. So look at B here. I've got 4 examples for you. And here's the key. I can't find a vertical line that hits more than one point. Now that hits one point, but only one. That hits one and only one. That hits one and only one. That hits one and only one. No matter what vertical line I choose, I'm only hitting one point. Therefore, this first one has to be a... If no vertical line exists that will intersect more than one point, then it is a function. Function. If it only hits one point, it's a function. If no matter what vertical line you pick, it only hits one point, it's a function. Second scenario. So again, I'm choosing vertical lines. How many points? Say it. How many points? How many points? How many points? How many points? What if I were way out here? Technically, it doesn't show, but would it hit at one point? Yeah, because remember, the line goes on forever. So therefore, the second one is a function or not a function? Function. By the way, if it's not a function, it would just be a relation, correct? Third one. All right, watch. Does that intersect more than one point? Does that intersect more than one point? Therefore, this must be a... Oh, wait a minute. I didn't hit more than one point, did I? Did I hit more than one point? So is this a relation or a function? Huh? We don't know yet? Huh? Do I need to keep going? Yeah. The point is, and you guys caught on, if there exists a line, so just because I drew two that didn't hit it, I could draw like a bunch more that don't hit it at all. All that doesn't matter because if I can find just one, here, let me fix that one. I'm going to put that one right here. If I could find just one that hits more than 1 point, then it's just a relation. So it's not like, well, none of mine hit it. Well, if you can find at least one that hits more than 1 point. Now, I want you to answer this question. Whom is guy one dating? Say it if you know it. Who is guy one dating? And let's assume that's right there, and we'll assume that that one's right there. Guy one is dating whom? Girl -1 and girl 3. See, that guy's dating two girls, right? And that's what's going to happen in this vertical line test. If the line, however many points the line hits, that's how many girls the guy is dating. That's how many outputs for that given input. Okay? And therefore, then, it is not a function. And it could hit in 2, 3, 4, 5, 9, a million, and it would only be a relation. All right, how about the last one? What do you think? Go ahead, you do the last one. Function or just a relation? Function or just a relation? That is the question. Whether it is nobler in the minds of men. And everybody says function. No matter what vertical line you choose, it's only going to hit 1 point. By the way, that's a graph of a sine wave or a cosine wave, but that's for another day down the road. All right, you have sine and cosine buttons on your calculator. We'll play with them this year. Awesome. Can't wait. All right, maybe some of you played with the sine button already. Your sin button, right? You're like sinning away. I'm sinning away, man. Hit that button. All right. Hopefully you got right with God after you sinned away. No, it's a sign button, and we'll play with that later on. All right, I got to get rid of my shade because I need to go higher. Okay. So that's the first thought. Vertical line test. It's a cute little way to figure out if something graphed is a function or not. And again, the key is if that function is over any horizontal point, then there's more than one output for a given input, or in the vernacular, any guy's dating more than one girl. So again, if you can find a vertical line that hits more than 1 point, then it is not a function, it's just a relation. If any vertical line only hits 1 point, it is a function. All right, number two. Here's a key concept, and this is an important concept. We're going to learn special ways to graph a lot of things. We're going to learn a special technique to graph a line. We're going to learn a special technique to graph absolute value. We're going to learn a special technique to graph parabolas. We're going to learn down the road, Mrs. Winterow, when you get her, you'll learn a special technique in graphing ellipses and hyperbolas and cycles and all kinds of stuff. But here's the baseline reality. Anything can be graphed using an XY chart. Anything can be graphed using an XY chart. Now, it's important to remember. Because when you can't remember the special way to graph something, you know what? Do an XY chart and graph it anyhow. What does that mean? Let's go through and take a look. Okay. So students tend to struggle a little bit in the language of the math in this first one. So let me try to explain to you. This is called set builder notation. That's its name. Don't get all caught up in it. I tried to color code it to make it easier on you. If I were to read this, this is how I would read it. E is the set of all XY pairs such that, the vertical line is a such that, y equals x plus 1 if x equals 0, 1, or 2. Now, to be honest with you, that first part doesn't mean a whole lot. This part right here is our function or relation. And what would the red be? What would the red be? Say it if you know it. The domain. So the red is the domain. So in this situation, they're telling us what values to choose for the domain. We want to know who guy 0 is dating, we want to know who guy 1 is dating, and we want to know who guy 2 is dating. How do you find it? It's very, very simplistic. Take your relation or function, and where the independent variable is, and by the way, the independent is the x, the dependent is the y, right? Where the independent variable is, stick in the first value of the domain, right? A 0. So when you solve that equation now, y equals guy 0 is dating girl 1. I'm going to take my green, I'm going to go to the graph, and I'm going to graph that point. So guy 0 is dating girl 1. I'll put a point at 0, 1. Now I'm just going to repeat that for the second value of the domain. Again, it is important that you put a parenthesis where that independent variable is. In this one, it's not such a big deal, but later on, it becomes important. You'll see that. All right, second time, we got to use 1. And see, we're filling in our XY chart. All right, so guy 1 is dating girl 2. And again, I'll take my green and put a point at 1, 2. And you can see the third one already. Guy 2 is going to be dating girl. So guy 2 is dating girl 3. And when I graph that, I get that point right there. All right, let me just throw something out. Just to see if you see anything that's noticeable. Though we weren't given this as a domain, what if they said guy 99, who's he dating? Girl 100. Right. Guy 1212. All right, let's mess with your brain a little bit. Guy -10. Girl -9, right? All right. Girl -9, right? Would be with guy -10. All right, but you know what? On this one, we said, hey, only guy 0, guy 1, guy 2. So that's it. So let me ask you first off, is this a function, yes or no? Does it pass the vertical line test? Yes, it is a function. Is any guy dating more than one girl? No, guy 0 is dating girl 1, guy 1's dating girl 2, and guy 2 is dating girl 3. No guy's dating more than one girl. No matter what vertical line you choose, it only hits one of the points. Domain. All right. So the domain 0, 1, 2. That was pretty simplistic. And our range is, say it if you know it, 1, 2, 3. And that's it. All right. And we graphed that using an XY chart. We said whether it was a function or just a relation. And we gave the domain and the range. Ooh, here's a little bit different scenario. So again, here's your function, right? And this part is your what? Domain. Now, see how we got to apply what we learned last chapter with conjunctions? But there's one other thing. It also says that each x is a member of, anybody remember what number set is capital Z? I think I heard it. Integers. All right. You say, I would have never known that. Yeah, I know. That's why I'm doing it for you, all right? I'm cluing you in right now. Is 1.5 an integer? No. No, it's 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. Just those are integers, right? Okay. Now let's go list our domains in the XY chart? I always like to start lowest and go to highest. Somebody raise your hand and tell me the lowest value of the domain. What is the lowest value of the domain? Okay, thank you, somebody. I was looking for a hand. -1 is the lowest possible x value. Somebody raise their hand and give me the next lowest x value. John? Not yet. You're skipped a whole bunch. Josh? 0 is the next lowest x value. Somebody give me the next lowest. Kaylin? 1 is the next lowest x value. Kirsten? 2 is next. John? Now it's time for 3. Is there any more? No. No. All right, let me pause for a second. Let me show you. Don't do this on your graph, because I know some of you did not catch on. I don't know if I caught that X and I didn't mean to. If I were to graph this as we did conjunctions, would not I do this? Right? Wouldn't that be the graph of that? Didn't we do that last chapter? Yes? Now, which are the integers? -1, 0, 1, 2, 3 are the integers, right? That's where we got the -1, 0, 1, 2, 3 from. Because we understood that this is from -1 to 3, but only the integers from -1 to 3. Okay? All right, so you had to be able to get that. Now we're ready to go ahead and start figuring out who our girls are. All right, here's our function. Y equals -2. There's nowhere for the x to go, is there? There's nowhere to put in -1. Hey, guess what? When x is -1, y equals? When x is -1, y equals? -2. Let me do the next one. This is going to get boring. When x is 0, y equals? -2. And guess what? When x equals 1, y equals? And when x equals 2, y equals? Girl, -2 is really getting around here. And when x equals 3, y equals? -2. All right, let's grab our green. Let's graph that. -1, -2. 0, -2. 1, -2. 2, -2. 3, -2. Right? -1, -2, 0, -2, 1, -2, 2, -2, 3, -2, 4, 5, -2, 6, -2, 7, -2, more. What is that from? Somewhere in my childhood past. I don't know. It's from something. All right, whatever. You guys obviously don't play that game anymore. Is this a function, yes or no? Function or relation? Function. It passes the vertical line test. Byron, give me the domain, senor. Now we're going to list them. So give me the list of the domain. Yep. 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 Is that it? I agree, right? We listed the members of the domain. Antonio, give me the range. Anything else? That's it, right? -2 is the range. Do you concur? We concur. All right. Beautiful. For spacious skies. Next. Ooh, yawn. C. All right, so here's another scenario. Uh-oh. Now we got a plus-minus thingy. But we do have a clear domain, yes? Okay. So our domain is -1. Hang in there now. Don't go too far ahead on this one. All right, here we go. Y equals, I'm going to put a plus sign. I'm not putting plus or minus, parentheses, and then squared. and I'm going to put the negative 1 in. I'm doing the plus first. What's negative 1 times negative 1? Negative times the negative is so negative 1 times negative 1 is, we have the point negative 1, 1. Let's graph it. Again, I'm doing it in green. Negative 1, 1. Hopefully you agree is right there. 1 to the left and 1 up. Negative 1, 1. Okay, here's the trick to this one. You say, Mr. Scarvey, I would never know to do that. I know. That's why I'm showing you. All right? Now we have to use the minus sign again for our negative 1. We got to use negative 1 twice because of that plus minus. Now when we do negative 1 times negative 1, we get 1, but now what's in front of that 1? So this result is negative 1. And therefore we have the point negative 1, negative 1. Can you already answer the question of whether this is a function or not? Yep. This is just a relation. We already know that from our first set of points. Now we got to do 0. And notice on this one, we're going to do 0 twice, the plus part and the minus, and we're going to do 1 twice, the plus part and the minus. And that's how you got to do this one. So y, 0 is kind of boring. 0 squared is 0, so 0 is 0, right? And what's the negative part when you do 0? It's still 0 again. So this one turned out to be 0 both times. So there's just 1 point there. But now we got to do the 1s. And again, one time you got to do it with positive. And I'm going to write them both right now. One time do them with negative, right? Say again. I wouldn't know to do that. I know. That's why I'm showing you that with the plus minus, you got to do each value of the domain one time with the plus and one time with the minus. So these are both 1. In the first case, you get positive 1. In the second case, you get negative 1. And so it looks like a 5, right? That's the way that thing ended up looking. All right, could you write the domain? Well, again, it's negative 1, 0, 1, right? We don't repeat anything twice. What does the range end up being? What's the range? Say it if you know it. It's also negative 1, 0, 1, right? And that one, the range and domain ended up the same. All right, number 3. My time is quickly wasting away. All right, what happens if no domain is given? Then the domain might be all real numbers. And that's how you have to treat it. If no domain is given, then the domain is all the real numbers. And I'm going to put the symbol here, right? Say, what in the world? I have to graph forever? Thankfully, no. Okay? Thankfully, no. Here's what we're going to do. We're going to learn, and you don't know this yet, but we're going to learn that the graph of this thing, oops, I want my blue, is a line. How many points does it take to determine a line? You learn this in geometry and in pre-algebra. How many points does it take to determine a line? 2. However, we're going to do 3 points because if we do 3, then we'll know exactly if we're correct or not. And so we're going to do 3 points. Now, you get to choose. You can choose any values for the domain you want. If I were you, I wouldn't choose like 30. Because you know what? You're going to need a big Cartesian plane if you choose 30. You can choose any three values of the domain you want because everything is possible, right? It's all real numbers. The best one, and I always would use first, is 0. 0 is great to use for the domain. So again, I'm going to write the function where the variable is. I'm going to put a parentheses, right? I took the y equals negative x plus 2. I'm going to put a 0 in here. And my y is a 2. So it's the 0.02. All right. And so I know the bell's going to get ready to ring here, and I got to figure out how I want to finish all this off. So this is what I'm going to do. I'm going to finish the rest by video. Okay? Just no other way. It'll be on HCS math class by the time you get home. Should be about 3 or 4 more minutes left. But I'd rather not try to rush to finish. And now that I realize so many of you are gone tomorrow, no sense giving the few left a quiz. So we will not quiz tomorrow for the few of you that are left. The question is whether I want to try to squeeze it in Thursday or not. Right now, consider the quiz to be Thursday. And if I change my mind, I'll let the class know tomorrow. But consider right now the quiz to be Thursday. Okay? No quiz tomorrow for those that are left. So again, homework tonight. And this will take me about 5 minutes to finish this up by video. And I'll post that tonight, HCS Math class. If you want it on your flash drive, leave your flash drive with me and I'll put it on there for you, Pamela. No, turn it in before you guys leave tomorrow. Turn in your homework before you leave.